think I also mentioned what the answer to 3.1 was yesterday. So they were just asking for the angle of inclination of QR. So like I said, QR is this line here. All right, so did they ask for the angle of inclination or did they ask for the reference, the acute angle? The acute angle. Okay, sorry, that's why I stopped at that. Okay, so they didn't actually ask for the angle of inclination. They asked for the acute angle between QR and the x-axis. So like we said here, this theta would be the angle of inclination, but the acute angle is the reference angle. Now guys, yesterday when some of you were coming up and asking questions, I could see that some of you are getting confused with which one is the reference angle and which one is the acute angle. Okay, so just make sure that the reference angle is the one that is, let me say it the other way around. The angle of inclination is always coming from the right-hand side, all right? The reference angle will be the acute angle that's coming from the left, okay? And you're not always going to have a reference angle. You only do the reference angle when your gradient is negative. So that's what happened in this case. When you're calculating that gradient, you do change in y over change in x. Now this calculation could have been the other way around as well. You could have said -5 minus 2. So like this, if you said -5 minus 2 over 7 minus 4, that's perfectly fine. We'll get the same answer. All right. So it's still -7 over 3. Now, guys, if this was just a straightforward angle of inclination question, you would have to say, okay, it's negative. So I have to find the reference angle first. Okay, some of you were saying that theta is this, and then you were doing a reference angle afterwards. Reference angle is always before the angle of inclination. So you get this by saying shift tan of just the positive value. Please remember that. All right, as positive 7 over 3, you get that answer. And that is the acute angle that they were asking for. If they were asking for the angle of inclination, you still would have had to say theta equals 180 minus this. Okay, that's just quite important, understanding that difference there. Yeah? In this case, can we just go straight to the No, you can just go straight to it. Yeah, I'm just writing it here so that you remember. Okay, for 3.2, there they were actually asking for the angle of inclination. So we said yesterday that we were going to call that angle theta. So the angle of inclination of PQ means that you have to find the gradient of PQ. Now you could have swapped your order around here. You could have said -2. No, sorry. You could have said 2 minus -1 over 4 minus -1. Could have done it that way around as well. You'll get the same answer. So the gradient there was 3 over 5. Now that's because it's a positive answer. You're not going to do a reference angle, right? You're not going to do RA. If your gradient is positive, your angle is going to be what you're getting when you do shift tan. Okay, so you're not going to write RA therefore. That is just going to be your angle. Because they said in the instructions for this one round to 1 decimal place, we have to round that to 31,0. All right, so normally it's 2 decimal places. Why they say to 1 decimal, but that was 31 degrees. Then PQR, we did discuss this in class yesterday. Would we have that 66.8? We have that 31. We now have to find PQR. It was angle sum and pi. Right? I think most of you got that. So you would say 180 minus 66.8 minus 31 degrees is equal to that. Now, guys, in a test or exam, if you got this angle wrong and that angle wrong, right? But you're working with the answer from 3.1 and the answer from 3.2, and you're getting a value there, we will CA that. Okay, so even if you got your first angles wrong, then I suppose if you are noticing that you just have to say 180 minus these ones, and you couldn't work them out, just again get something. So for 3.1, just write an answer, and 3.2, just write an answer, and then work with those guessed values. Okay, 3.4 was asking for the angle of inclination of PS, SP, so this is one that we have to extend. All right, that one there. So we called that one alpha, we said yesterday. So again, you just find the gradient of SP, which was 3. You do shift tan of 3, and then you get your answer. Any questions before? All right, 3.5. Yeah, okay, let's quickly talk about 3.5. So in 3.5, they were asking for SPR. Okay, now I've already called that in because I calculated it, but obviously we don't know what that is yet. So they asked for SPR, this angle here. Now guys, according to the steps that we wrote down, you need to find the angle of inclination or angles of inclination of the two lines that form this angle. So we had already extended that one and we calculated that angle of inclination, right? So then I said you must also extend this one. So this is the other line that's forming this angle. Then you're going to calculate that one. All right, so that was the first part of 3.5. You can see it there. Term P, we decided to call that one is the gradient of PR, that one that I extended with the pink line. So the gradient is negative. So whenever the gradient is negative, you have to find the reference angle first. Okay? Then you can find the angle of inclination. So guys, you notice that I didn't actually even find that angle P, right? I just got as far as getting the reference angle. I'll come back to this just now. Because when I pulled that in, 26,6, right? The reference angle is that acute angle there. Do we agree that it's the same angle as this one at the bottom? Those are the opposite angles, right? So I saw that, okay, I don't actually need to even find this angle because I can already move towards this angle just by using the acute one. Okay, if you calculated P, that's fine. You're not going to lose marks for calculating it. All right. If you calculated this, then maybe you use angle on a straight line to get that angle. That's fine. All right, it doesn't matter. Then I looked at this 71.6-degree angle, that one there, alpha that we calculated earlier. Do we agree that these two are equal to each other, again vertically opposite angles? And now guys, this is quite small. Let me just zoom in so that you can see nicely. And this is now where you must be very careful if you're filling stuff in on your diagram. Right? We're supposed to find this angle here. Now these two angles are equal. You see I put a dot in each of them because they're vertically opposite angles. So I'm actually using vertically opposite angles 3 times in this one calculation. All right. So vertically opposite angles there to get that one. Vertically opposite angles there to get that one. And now how can I find this angle if I have those two? Angle sum and triangle, right? In the small triangle. So if I say 180 minus that one and that one, I'm going to get this angle, which is equal to SPR, the one that we're trying to find. Again, because of vertically opposite angles. Okay, so guys, please, I encourage you to fill in whenever you are calculating an angle, please fill it in on your picture. It will make it so much easier. So you can see then how I wrote that out. I then just said that SPR is going to be 180 minus those two angles that are in that tiny triangle. The reason for that is angle sum and triangle, and then I use vertically opposite angles a bunch of times, so you only have to write it down once. Please just note this reason, guys. This is a strange reason. In the CAPS document, they have an equals at the end of that reason. So I don't know how strict they're going to be on this, but the full reason, according to the CAPS document, is vert of angles equal, not just vert of angles. So just add in an equal for me. I should actually post that list of reasons. So I'll put that on your Google Classroom so that you can see exactly which reasons are not to use. Okay, then I got an answer of 81,8. Then 3.6, I told you to not do that one. You could try it if you wanted to, but I actually need to show you a different method to calculate that one. Because that line that we need to find angle of inclination of, we can't extend it. Okay, so we need to have a different method. So in 3.6, where they're asking for PSR, that's the question. PSR, I think. PSR, yes. I'll go back to that page now because I'm going to write my answer down there. Now, if we're trying to find PSR, which is PSR is this angle, right? I'm trying to find that angle now. Now, we can think of multiple things to do here, I suppose. You could possibly, I'm just looking at it now and I'm seeing that this is a triangle, right? Maybe because it's so difficult to extend this line and actually to get it to cut the x-axis to find that angle of inclination, maybe we can find that angle instead. Right? I have that one, 81.8. If I can find this angle somehow, then I can do angle sum and triangle. Right? That could maybe work. Is there a way to find this angle? Oh, this is the same thing. All right, we also need that angle of inclination. Okay, someone needs to get creative and maybe use alternate angles because there is like a Z shape there. Unfortunately, they have to tell us that the lines are parallel in order for us to use alternate angles. And in this case, we can't do that. Okay. This is a method that they use in the textbook, so I will write it down as well. What I want you to do is to take your ruler and draw a horizontal line going through the point where the angle is. You can write those steps down now. This is a different method that you can also use. So we are adding in that line. You see that pink line in the bottom. But guys, the reason why I'm doing that is so that I can possibly use fuzzy X stuff. So let me just check. Okay, we'll see. Right, we're drawing in a line that is parallel to the x-axis, right? That goes through that point. So guys, we're going to have to do some visualization here. This is a difficult one, okay? If we can visualize this line, if it actually did cut the x-axis, right, somewhere else, that angle of inclination, right, the angle between the x-axis and this line is going to be this angle. Same as that one. It's difficult to try to visualize that. This line that we've drawn in now is parallel to the x-axis, right? So if I take this line and I extend it and it cuts through the x-axis, it's going to have exactly the same shape as that gap over there. So this small angle here at the bottom, I don't know if you will actually get a question like this, but let's just do it. This angle there is actually going to be the angle of inclination of RX. It's almost like you're drawing in the x-axis lower than what it really is, in a sense. So guys, if we're looking at this line, the way I'm showing this line, what is this? PS, because which lines form this angle? PS, right? Have we calculated the angle of inclination of PS earlier? It was alpha, right? So guys, do we see that we have an F shape here? Difficult to see because it's an upside down F shape, right? Maybe you can highlight that or something if you want to. Just look at where my pen is moving. That is an F shape, right? Do we see that? What do we call the F shape again? Corresponding angles. We remember that F shape. There. Now guys, we drew this pink line in so that it's parallel to the x-axis, meaning that if we have an F shape, this angle here is going to be equal to that angle there, the big angle, right? Not just the one that we're trying to find, but the whole angle from PS to this kind of new x-axis that we've drawn in. That is going to be the same angle. Should I highlight it? Let's see. I'm highlighting that F shape here. Did that help with it? Then upside down one, right? F shape. Do you remember that according to fuzzy X, the F shape has corresponding angles? And if the corresponding angles lie on parallel lines, then they are equal. Right, we just drew in this line now. It's parallel here. I know it's difficult, it is a bit of a stretch, okay? But I'm hoping that you guys can see that F shape there. So guys, we actually have that big angle there, that alpha. We know that that big angle, right, the whole angle here, which is consisting of these two parts, is equal to 71.6 degrees. Okay, we calculated that earlier. So guys, I am wanting to find this angle here, right? Back on me. Do you agree that if I have the whole angle and I minus this middle one at the bottom, I'll be left with that one? Okay, and we'll say that again. We have the whole angle now, right? So we'll want to be 1.6. If I can work out what this little angle is here at the bottom, then I can just minus it from 1.6 and I'll be left with the one that they offer. Okay, and what is this little angle again? The angle of inclination of RX. We know how to find that. How do you find the angle of inclination of a line? Tan of the angle is equal to the gradient. Okay, so for 3.6, the first thing we need to do, we need to find tan of, what are we going to call this angle now? Run out of symbols. Tan of, okay, how do I put it? Triangle. Okay. Tan of delta, yes, thank you, is equal to the gradient of, and what is that line now? Rs. Okay, to find this little angle, the gradient of Rs. Now we need to work that out. We need to calculate that gradient. So if we're looking at the coordinates, we can say -7 minus -5. That's going to go at the top, change in y, -7 minus -5, and then -3 minus 7. Okay, so -7 minus -5 over -3 minus 7. That is -2 over -10, I think, which is 1 over 5. Can someone just check that for me? Thank you. Right, so 1 over 5, that is the gradient. It's positive, so am I going to calculate a reference angle if the gradient is positive? No, only if it's negative. All right, so to find this angle now, all I need to do is shift tan of 1 over 5. And that is 11.3 degrees. A small angle, we could see on the picture already, it was quite small. All right, 11.3 degrees. I'm going to go back to my picture. I'm going to fill that in. 11.3 degrees. Okay, so like I said already, guys, I know that this whole angle is 71.6. Now I'm just going to minus that 11.3 degrees, and I'm going to be left with PSR, the one that they asked me to find. Okay, so now we're going to say, therefore, just write it on the side here, PSR is equal to 71.6 minus 11.3 degrees. Now, right now, I'm going to say angle, sum, and triangle for that. What am I actually using? What did I use? What like fuzzy X thing did I use in order to get those corresponding angles? Thank you. Corresponding angles. I don't have enough space in that line, so I'm just writing it on the side. This is another thing. You're also not allowed to just write CORR. You have to write it like this. Corresponding angles. And these lines don't have names, right? Because I actually drew this one in. So you just are going to have to write parallel lines. Remember, whenever you're using fuzzy X, one of those things that rely on parallel lines, you have to write that the lines are parallel. Okay. Now, what is this? Is this 60.3? 60.3 degrees. There we go. Okay, so that was a very tough one, guys. I'm going to write a little note at the bottom here. I'm going to say if you cannot extend the line to cut the x-axis, then this is what you're going to do. Okay, so just make a note. See if you can do it underneath. Yes, yes. But guys, usually you don't have to do this. Okay, so I don't want you to feel put off by this. This was the last question in the exercise. It was the hardest one. We're just writing a note down just in case, but I don't think you will have to do this in a test exam. It certainly hasn't come up in years. If you cannot extend the line to cut the x-axis, then draw a line parallel to the x-axis. Right, so we drew a line like this, parallel to the x-axis. It will always be a horizontal line through the point where the angle is formed. So what I mean by that is it was angle PSR, so we drew a line through S. That's always where that angle is through that point. Then you are going to use fuzzy X and angles of inclination. To calculate the angle. Okay, I printed a note for you guys. I'm going to hand that out so long while you finish copying that down. Question is now just where did I put it? We need a better filing system. Okay, you can make a new heading so long. You can write analytical circle geometry. Sounds much worse than it really is. Analytical circle geometry. And guys, this is actually the trick work that we do in grade 11 already, so that you can get lots of practice in it by the time you have to do it in your matric finals. But that does mean that we are not going to do analytical geometry at all next year. So it will be in all your exams going forward, in matric and in grade 11, but we're not going to actually like have time in class for me to explain it again. So it is quite important that you are up to date with what we're going to go through now. Maybe it's in my grade 11 file. Yes. Okay, guys, basically what you need to know on this page, very important, is this formula. All right, this is a formula that you need to know off by heart. Tomorrow we're going to be doing a variation on this formula. Okay, but today we just work with this variation one. Now, last year you did circle geometry, but that circle geometry that you did last year was Euclidean geometry. This is analytical. All right, the difference between the two is that analytical geometry is on the x and y axis. So you have coordinates, right? You have points that lie on the circle, for example. If you just remember last year's Euclidean circle geometry, those were the stuff with all the theorems, right? You also have angles, but you have to calculate angles and stuff. It's very different. Okay, we're going to do Euclidean circle geometry again later this year. But this is something brand new. You've never done this before. Okay. Now, this little bit is basically explaining where the formula comes from. You don't have to worry about that. You're never going to be asked to prove it. You have to know this formula and you have to know what it means. All right? X represents X values. Y represents Y values. And the R is the radius of the circle. All right, so it does say that there, but yeah, let's highlight that. This is the equation for a circle centered at the origin with a radius equal to R. So that is like the circle that we have here. All right, the center of the circle is the origin. Do you remember what the origin is? The point 0, 0, right? So this circle is centered at the origin, meaning that the origin is literally the center point of the circle. Okay, tomorrow we're going to look at what happens when it moves, when it's not at the origin. Okay, now there are some examples here for today. We're just talking about how you find the equation of a circle, all right? So here, this is important. To find the equation of a circle at the origin, there is only one unknown value, one value that you actually have to find an answer for, which is the radius, all right? In your equation, guys, it's always going to be x squared plus y squared equals to an alpha. Right, that is what the equation is going to look like. If we look at this block up here, x squared plus y squared equals 25. That is the equation. All right, you're always going to have x squared plus y squared, and then just whatever the radius is squared. Okay, it really is as simple as that. So that is how you're going to find the equation always. All right, sometimes we're going to have to find the length of the radius. So if we're looking at this circle here, Right, we understand what a radius is, but it's from the center of the circle to any point on the circumference. How does it read it all here? What's that? From 0 to 5, that's a radius. Right? 5 units. You see y is 25. X squared plus y squared equals 5 squared. The radius squared. Right? So it's really not that bad. Unfortunately, sometimes they don't give you that information, right? They give you other information. So there are 2 examples here, and they're already typed up, but I do want you guys to pay attention. You're going to practice this after we're done going through this example. Determine the equation of a circle, center the origin, passing through the point -4, 7. But as they say center the origin, you have to think immediately x squared plus y squared equals r squared. That's like the standard form, right? Like when I say to you a straight line, you think immediately y equals mx plus c. All right? When I say circle center the origin, you need to think x squared plus y squared equals r squared. Okay? Now guys, they didn't give us information. If we just read through this question, they did actually, we could have found it in a different way, right? They're telling us that the center is the origin. What point is that? The origin is 0, 0. Okay, and they're saying that it's passing through the point -4, 7. And as the circle is passing through that point, that point lies on the circumference of the circle, right? So on the actual like border of the circle. So what you can do here, this is the quickest way to actually find the equation, is to just sum in that point. Right? Because what is a point? A point is always an x value and a y value. So what you can do is you can just sub in -4 for x. Look at that. X squared is now -4 squared. And y squared, what is the y value of this point? 7 is 7 squared. And that will be equal to the radius squared. Right? So from that, -4 squared is 16. 7 squared is 49. 16 plus 49 is 65. That is r squared. What is the equation? X squared plus y squared equals r squared. So as soon as you have r squared, you can just put it in the equation, and that is the final answer. And that's it. You just sum in that point. You work out what r squared is. You can just type it into the calculator. All right, and then that is your equation. I hope that makes sense. Put in the x value of the point for x, the y value of the point for y, and you get the answer for r squared. Guys, could I sum anything into r? Did they tell me what the radius was? No. If they told me what the radius was, it would have been very easy. Then I could have just done x squared plus y squared equals that radius squared. Okay, but they just gave us a point, so we have to, so irritating, this thing keeps freezing. We have to sub in that point, but we are then able to calculate r squared very easily. Alright, if we have this equation, x squared plus y squared equals 65, they can ask you what the radius is. Okay, now the formula is x squared plus y squared is the radius squared. That means that the radius squared is 65, right? The radius squared is 65. You can obviously write that as r squared. I'm just writing out the word so that we keep remembering what that r is. So how am I going to find the length of the radius? The radius squared is 65. I'm going to have to square root it, okay? So the radius is going to be the square root of 65. Okay, which you can work out what that is. Let's see in decimals. They just left it as root 65 here, but we can, of course, work out what that is if you press SD 8,06. Yeah.
So they ask us to find the radius.
Yes. Yeah, I'm going to say that now. So if a different method to finding the equation is to actually use the distance formula, right, to work out the length. Because remember, the radius is going from the center to any point on the circumference, right? And we have a distance formula. The distance between 0, 0 and negative 47, that will give you the square root of 65 if you work that out. Okay? I'm going to write here, or use distance formula to find radius. And I'm just going to write here between 0, 0 and negative 4, 7. That will give you the length of the radius. Then you must just make sure when you put it into that formula that you must square it. Because again, there's no correct method of doing this. Okay, you can choose. Do you just want to start at a point and calculate r squared like that? Or do you actually want to calculate the length of the radius using the distance formula and then square it? Both methods will work. It's up to you. Okay, are there any other questions on that one? The next one is very similar. Example 2, determine the equation of a circle. Again, they're saying center the origin. So again, I'm going to highlight that. As soon as you see those words, center the origin, I want you to think of the standard form of that circle equation, x squared plus y squared equals r squared. It is going to take some time to get used to that. It is something completely new. All right, but please make sure that you highlight that. Because the center is at the origin, that is the equation that we're working with. X squared plus y squared equals the radius squared. Again, they're just telling us that it is passing through the point 5, negative 12. So you can do what they did. You can just start in that point. Remembering that x is now going to be 5. So you're going to say 5 squared plus y is now negative 12. So you're going to say negative 12 squared. And that will give you r squared. Okay, so you just work that out. You don't even have to show this middle step, right? You can just type this into the calculator straight away. You're going to get r squared, that is 169. All right, so the equation is x squared plus y squared equals 169, r squared. Okay, that's all you need to write for your equation. If they are asking for the radius, then because the radius squared is 169, the radius is going to be the square root of that, which is actually 13 units. Okay, if they ask for that as well. Or you can use the distance formula to calculate the distance between the origin 0, 0 and that. Okay, do you have any questions on that, guys? That's all we're doing today. I'm just going to show you where to find this because this is not from a grade 12 textbook, which you obviously don't have. So if you go onto the grade Google Classroom, let me just open it here quickly. If you go onto grade 11 maths and you go to classwork and you go down term 1 analytical geometry, there you'll see number 5 circles, right? Number 6 is this note that we're looking at now. So we've done the first page of it. But number 5 is the actual chapter from the grade 12 textbook. Okay, so there it starts on that section. So they say circles. So you can also read through this if you're not understanding. There is some more stuff. There's some more examples that you can look at. This textbook goes much further than you are supposed to go, though. So don't stress about, there's some very complicated examples that you don't actually need to do. What is this saying? This is saying exercise 10.2, right? So it is, let me just see, is there 10.1 even? Oh, 10.1 I think was this exercise, all right, which was other stuff. So circles, exercise 10.2 is the first one. It is on page 252 of this document, right? So you'll have to look at the actual page number there, page 252. And you are going to do, let me just check, A, B, F, and G. Okay, yes. 2A, C. On this page that I handed out, can you draw a line through 2E? I don't want you guys to do 2E. So it says at the bottom of this page where it's listed what you need to do, it says 2A, C, and E. Just draw a line through E, please. And 3A, C, also draw a line through E, please. Okay, so I'm going to circle on the board the other one, which is do and then we put the same picture of that. And we're going to go very through faster. So it is 1. This is page 2.2 is down there. And G. 2A and C, and then 3A and C. It looks like a lot of you guys are just for practicing this, just practicing that formula that we have to have. So number 1, they want the equation. So they want x squared plus y squared equals r squared. So in the first two, they're giving you the radius. So that's easy. How are you going to find the radius squared if they're giving you the radius? You just go squares, correct? So for the first one, radius is 7. So it's going to be 7 squared, 49. Okay, so that's going to give you an equation of equals x squared plus y squared equals r squared. If you want the equation for the first one, it's going to be x squared plus y squared equals 49 squared. Right? For f and g, they're given you points. So f and g, you can do like the one in the example. So we start those points in. And then we find it weird. For number 2, then given the equation of 2 circles, we need to find the radius. Remember that this is the radius squared. That is the radius squared. Then you use that to get the length of the actual radius. And then for number 3, you're saying determine the radius of the circle with a theta at the origin, which passes through the given point. They're not saying you have to find the equation for these ones, right? But you can if you want. But there's also another way of actually finding the radius if you have the same analytical. Okay, you can do this one. Cool, you can do that now, right? You can definitely finish within the 15 minutes that are left, then you don't have homework.